Abhishek Nag, Neeraj Pandya.
Yes, good evening.
Neeraj Pandya, you are coming first time?
Yes, I am coming first time.
Please introduce yourself.
I see. Basically, I'm this field from last 24 years. From my first job, started doing designing of pressure vessel and heat exchanger, and now after 24 years, I have an experience of designing pressure vessel, heat exchangers, reactors. And I have started my calculation on the basis of Excel sheet and manual calculation. Now I'm comfortably able to do job with PV light also.
So totally you have around 24 years experience, right?
Yes.
So you are still working with some company or you started your own?
No, right now I just started my own.
Okay.
Yes, I'm right now working as a consultant.
Baroda. Okay, Gujarat.
Yes.
I think here it's better if you tell your company name and that it's get advertised also here if you inform me.
Yeah. Yes. Now I have started just 15 days back.
Okay.
And I've started my consultancy with one of the company for ASME EU certification. I am guiding them how to achieve the ASME EU certificate for their workshop and their facility. I'm training those engineers, design engineers as well as quality engineers for the mandatory appendix requirement. So it's my first month rather. And I also started working with one of the company for providing them the designing of the equipment.
So you given your company as some name or still it's in pending?
Right now, sir, I have started with only my name.
Okay. Still name is not finalized yet.
No.
Okay. Best wishes for your newly started company.
Thank you, sir. Thank you.
Okay. I think you have any specific issues that you want to discuss here? Anything or any solutions you want to highlight?
No, right now I'm just. I just wanted to attain this kind of conversation, and would like to know the basic problems with the pressure vessel designing and reactors designing or heat exchanger designing. And during discussion, if some my help is required, then I could able to extend it. That's why I have joined this group, sir.
Okay. You have 24 years and ASME, that type of jobs means you have you have better hand on that one, the designing of equipment. Okay, however, well, best wishes for your new company.
Thank you.
Okay. Abhishek Nag, I think last time you missed, right?
Yeah, hello, good evening everyone.
Yeah, good evening.
Welcome Neeraj.
So you know Neeraj?
No, I don't know Neeraj. Neeraj has introduced mission. So I got to.
I think Abhishek Nag also having around 20 years, right? Abhishek, you also 20 years experience?
I have 16 years of experience.
16 years, okay. Myself is around 24. And Ramakrishna, you also have around 23?
20 years.
Yeah, 20 years. And Atul Sharma is around 5 years.
Should I start with one of my queries?
Okay, we can start.
At present, sir, we are studying with one of the concern which we are seeing in this pressure vessel. There is it's regarding again that nozzle, external loading on the nozzle and flanges.
What is your issue?
So my issue is that by default we do for the external loadings on the nozzle. Okay, as per to RC 297. But my question is that why don't we check by default for the flanges also? Because the external load will come on the flanges. So if the load is quite high, it will bend the flange space, or there will be leakage. The gas pressure, so there could be a leakage. So why we are not checking it mandatory for flanges? In the previous section is UG-44B. If you check that box, generally performs that analysis. Question then why we don't perform it for the flanges?
Anybody want to answer his query?
Yeah, but you mean to say it's weld like flanges we are always considering, right?
Yeah, it's well next time. Correct.
That we are means it's already been given in code also, but I think you are referring SORF flanges, right?
No, this my question is specifically for welding race flanges, WNR flanges. So UG-44B, it says may be checked for weld neck triangle. External loading may be checked. Why not shall be checked?
Maybe next year they'll do it.
Maybe mandatory requirement, yes.
Actually, Abhishek Nag, you want this flange to be checked, compulsory, right?
Yeah, the basic thing is that you understand. Who in a layman language, say, who just want to understand. If the external load is coming, piping load is such that it's coming on the pipe, like nozzle, we are checking for that. Why don't we check for the flange?
No, yes. Shall I answer, Abhishek, your query? Yeah. Hello.
Yeah. Yeah. Please go ahead.
Yeah. So by default, everybody is checking. I mean, it's not in our all projects we are doing that, and most of the engineers are doing it. So there is no question about that. Don't do it. So it is a good practice. So I think your concern is about the code wording that they mentioned, maybe, right?
Yeah. Correct.
Yeah. So why didn't they put it shall be, right?
Yes.
Yeah. So normally this what I mean, as far as my point of view is, this ASME generally whenever puts some new clause or something new design method, I think they will give some some time before making it mandatory. I think so. That's why they'll put it like this, maybe, and then maybe after they get maybe some people will give feedback. So after that, maybe they will make it mandatory. I think that's the reason. That's what I feel. So if your query is answered, then I have a question to Neeraj.
I want to add something in this one.
Yes.
Like Abhishek told that now almost all the these flanges also started for U stamp and that one. No, they started
Yes.
compulsory verification of these flanges and that one. And normal vessels which is not U stamped, for that one they are saying that okay, maybe if you not done also it's okay. But this U stamp one means ASME certified vessels and that one, they want compulsory this flange to be verified as per now recent code update and that one.
No, actually, reputed EPC, I mean PMCs like U stamp. So for all our projects, none of the equipment is U stamped, but we are mandatorily checking it. So maybe I think, as far as my point of view, I think all oil and gas projects generally, most of the cases, it will be checked. Yeah, that's.
Yeah, all EPC and then they are also made compulsory to that to be verified.
Correct. Yeah.
Sir, what is happening? I am doing an argument with the client that you are saying that external loads to be checked for the flanges. But my argument is it is not a U stamp vessel. Nowhere in the specification is mentioned that we have to follow UG-44. So why us to perform one UG-44? Because when we perform UG-44, our plans rating is getting from 150, it goes to up to 300. We want to cost and
Yeah, flange rating and that one it increases, but it in long term running of your vessel it will be safer the way. If you verify with that one, the providing higher rating flanges and that it will be safer for your vessel to fail in between of working and that one. So that's why they want to verify that one. These loads are to be.
Yeah. So I have a question to Neeraj. In continuing with.
Yeah, you can. I think Abhishek is clear now.
I think just you were mentioning that how the nozzle loads will be analyzed there is a difference between WNR pipe and slip-on. Is that you were saying? Can you just throw some light on that? Yes.
In my earlier career, I have designed a lot of pharmaceutical equipments also.
Okay.
And just would like to go back to Abhishek's question, and I'll connect with this one.
Yes.
See, one of our ASME audit, we have our company has made air receiver. It's the first job. They wanted to make a demo vessel, and in air receiver, they have not provided any external nozzle loading.
Right.
So this team leader who came for the final audit, he told, you if not specified this external loading and don't go for this derating, then it's not mandatory. But in future, if you have a job, then how could you able to justify your design at that point of time? That what I would like to check. So it is not mandatory, but you have to specify, and so that your design engineer is capable of handling those external loading on the nozzle.
Okay.
So it's my requirement. How means they have asked us to specify the nozzle load as per API 661 and ask us to add those loads on the nozzle, and got it done with our design engineer, even though it's not specified in the code.
So API 661 means it is a plate heat exchanger, right?
Yes.
Okay.
API 661 is this one, air cooled heat exchanger.
Air cooled. Sorry. Yeah.
Yes,
662 is plate heat. Yeah.
Plate, yes.
Okay.
And this SORF lenses, see, all nozzle loadings are always there. Wherever the instrument nozzles are there is no nozzle loading should be considered. But wherever it is connected to pump or it is connected to any process nozzle, nozzle loading always will be there.
Yes.
So if pressure is less and SORF lenses will be connected, then code is allowing that you could not, means it's allowable that you should not consider the derating of the flanges. So that's why the
where it is specifically mentioned, there is a distinction between WNRF and SORF.
It is very clearly written in UG-44B that only WNRF flanges and not SORF flanges or any other kind of flanges applicable for derating. Yes.
Okay. So code is written for WNRF. Right. So my question is, what is the SORF flanges? Okay, although code is saying it is not required, but what is your general opinion? So there also it must cause some kind of this one, no? So leakage.
Correct. But what I understand from my experience is, if you see the weld-like flanges welded with the nozzle pipe is having butt weld joint, right?
Right.
But
correct.
When you are welding it with SORF flanges, slip-on, it's not weld, it's not butt weld.
Yeah, right.
It's a kind of type 7 joint, both side fillets.
Right, correct.
So it has, means it's my assumption that it doesn't have any worried about bending from one point, because it has been welded from two sides.
Okay.
So that's why nozzle loading would be, means it's not quite conservative to be considered in that case. That is only my thinking. I have never cross-checked with anyone. But butt weld, there is no support. If weld fail, then bending, loading and all other loadings will take place immediately and start leaking out.
No, but if you think about, in terms of strength point of view, if you see WNR flange is much stronger compared to slip-on.
Correct. For pressure rating.
You're saying no, so there are two welds, so it is slip-on flange, I think it will take more load and all kind of thing. I think that I disagree. But maybe, I don't know. It could be that maybe it is flexible, maybe the connection is flexible, so maybe this is just, I also don't know. So
Correct. It is nowhere it is written. I have raised so many posts for this one in my LinkedIn and other, but I could not able to get any satisfactory answer.
Yeah.
And thing is, strength is okay, but when bending load comes, your lap kind of joint will withstand more than the butt weld. That is what I can feel. And this one is a kind of a lap kind of weld joint for particular that point. So maybe the bending stresses or bending moment will be much more easily can be absorbed.
Yes.
That is the only reason. But I have to check with some experts. I have tried so many times, but couldn't get through.
Yeah. So I mean, to add that, another thing is generally slip-on flanges will be used only in non-critical service. Maybe that loads are not too high. So maybe that is also maybe the reason.
Correct.
Yeah. Yeah. Okay. Thank you.
Normally, this slip-on and that one, it's means it's not that major service. Means
Correct. Yes.
it's used. And this weld neck and this severe service or maybe use stamp vessels or it's high pressure and that.
Yeah. So basically, weld neck flanges has to be used.
That will be used in that. But Abhishek question is on flanges. He's asking on the flanges, the loads on the flanges.
Correct.
So, so you are saying that slip-on flanges will take more loads rather than the weld neck?
It's not load. I am talking about the bending.
Okay, means slip-on takes more bending rather than weld neck.
Yeah. Yes.
Okay.
You also try to cross-check this question.
Yeah,
Why,
because normally in high pressure, high loads and that one we go for weld neck. And for normal service, there is no much load, much pressure, nothing. Then we'll go for slip-on on that one.
Because you assume if that nozzle will connected with the pump and pump has got some vibration, then definitely the load will bending load will immediately transfer to that particular welding joint. So maybe that bending load will be critical for taking care of that joint.
Maybe we have to. Okay, Atul or Anshul, you have any opinion on this one?
Yes, actually, slip-on flanges have more moment of inertia than weld neck also.
Moment of inertia means it takes
more
load.
Their mass is distributed more away from the center as compared to the weld neck.
Okay, so it will take
moment
more.
Of inertia is directly connected with the center, means the CG. So if you see the CG of a weld neck plane will be very close. Whereas now I got some idea from the unschools. So there are two weld joints. So CG will definitely shift it, and moment of inertia will be more. I think this is also a good logic, Anshul.
Yeah.
Okay. Due to that one.
Abhishek, for your question of flange rating, actually they have mentioned in MR that you have to check the nozzle duration, and if flange is derating and you have to re-rate the flange, first of all check that flange as per appendix 2. If it passes on that, then don't need to derate the flange. If it does not, then only you have to use the higher rating flange. They have written it specifically.
Okay, so this is in the specification of software. It's not in the ASME promo, so we cannot argue with the client that.
Actually, many people use the appendix 2 design to prove that nozzle load is not a consideration, because you have designed considering the worst case. No? Appendix 2 is more severe than the ASME 16.5 application.
16.5 they given the direct rating sizes and that one.
Yes. The 16.5 is being worked based on past data.
Yeah.
Rather than more theoretical calculation.
So means it's based on, as you said, requirement. It's not maybe Abhishek client may be different, so their client requirement may be different.
I was saying that even they are tired of raising the rating that they have mentioned it in the
Okay, Abhishek, I think you got your answer. That if you verify, it will be well and good. If you not verify, maybe in future you may face some issues. That's why
they are asking the actual load, which is for the piping. Okay, if you do the actual piping loads, then those loads you can put in the field, right? You will be able to see that what is the flange rating, whether it passed that load or not. But here saying that you do iteration, that you just tell me with what thing how much maximum load it can take, the flange can take. They are in the argument, they are in fact asking us to give us your load so that we will check with our piping.
Yeah, actually, whatever you putting in the PVL at that loads and that one, no, that's verifying at the edge of the that pipe, means that nozzle end, which is connected to the shell. So at that place it is verifying. But this derating, it's verifying at the flange face. So your flange is verified in this one, in derating one, and your edge is verified in PVLite when you put the loads on that one, WRC one. So these two are different, right? Anshula Ramakrishna.
Yes, but even on the see, if you are applying the UG-44, so it takes for space.
Yeah, flange
Not
face.
flange.
Either its flange is taking that loads and that.
You just tell me the figure, how much load 50 class rating can take. We'll check with our piping.
Yeah, that you have to verify with this one, UG-44.
And I'm asking that you give me the piping load in our calculation.
Yes, that is the better option. You can't just rerun analysis by entering the values.
Iteration then.
Yeah.
But normally these loads comes from piping, and we not means our static will not give that loads, means this much it can take, and reverse engineering they, because whatever they provide some supports for their piping and that one, they will just after end of our where our their piping is ending, which connecting to our nozzle, or that place they will provide the loads. This is the loads are where they arrived in piping, and they will give us, and we have to verify our nozzle. But rather than that one, if you provide from your side, this is the loads we can take, then again they have to means change their routine, or maybe additional support they have to provide to take off, means whatever the additional.
But generally we have the standard loads, no?
Yeah, standard some specification
Both
they
will
have
refer
the
to the
maximum
same.
standard loads. They some specification says that these are the maximum loads what piping can give to you. So you can take that also if you have the standard loads. Else you can ask your piping how much loads you are getting. So you can add that one.
Okay, thank you.
Yeah, coming to, I mean, Neeraj, I checked UG-44, but I didn't find that statement that it is applicable only for slip-on flanges.
No, it's applicable only for wind neck flanges.
Ramakrishna sir.
Yeah, please.
Can
Yeah,
you
actually,
share that
if
one?
you refer na B, UG-44B,
Yes.
they have
UG-44B.
written evaluation for flange joint with bell neck flanges.
Acha, where they mentioned.
Can you share the screen?
Okay. Right. Okay.
You got
Right. I got it. Yes. Yeah, I missed it. Oh, thank you.
Yes.
Now code has revised this 2901-1. They have come with the revised 2901 code case, because and they have changed the FM value which is being given in 44 table. So that FM value was a major culprit. So they have revised the entire FM value. And now if you have a 2901-1 code case, it shows that now a lot of flanges were failed. Now all the flanges could be very easily passed due to that revision in table.
Do you have that code case? Actually, I wasn't able to find that.
No, it's not available. I have checked on the website of ASME.
Yes.
But
So
I got
code case 2901. Yeah.
2901-1. 2901 was the original code case of 2019.
Okay.
They have revised again in 2024, just 1 month back.
Okay.
That is 2901-1.
I think Atul Sharma you supposed to share, no? This 29
I only have 2901, not -1.
-1. You don't have. Okay.
Yeah, 2901 I have also in the group, but -1 I don't have.
Once I will get, I will upload in the group. Don't worry.
Yeah.
Yeah, please. Because
I got that table in Excel sheet. I don't know how much we can trust, but I got that table, revised table I already have. If you want, I can just upload it. It's not authentic right now because I don't have a code case, but I can upload it.
yeah, anyway, you please upload.
Yeah, it might help Abhishek right now.
Right.
Okay, Ramakrishna, you want some more?
Yeah. So 1 minute. I will share it. Yeah. So my screen is visible, I guess.
Yeah, it's coming.
Yes.
Yeah. So this is an agitator vessel. So this is it's actually agitator vendor, agitator drawing actually. This is a drawing given by the agitator vendor. So normally we get the static load, but in this case he has given dynamic load actually. So how we can convert into static load? Anybody can provide?
Can you please repeat what actually your query?
No. So the load actually normally for the agitator vendors they will provide equivalent static load. Because this need to be analyzed. No, this load we need to put it on the nozzle.
Yeah.
Right, to analyze or to provide a proper support, we need to analyze it. So normally vendors will give the equivalent static load, but actually it is a dynamic, right? The dynamic it is a continuously rotating. So it will be dynamic loading, but vendors will provide equivalent static load. So they will convert some conversion factor and give the static load, and that we can put it in our PVLet and we can analyze. So, but in this case, vendor has provided only dynamic load. He didn't give the static load. So, can anybody guide how we can convert to equivalent static load?
But where it is given, it is a dynamic.
No, because you see this. You see this. You see this PIC1, PIC2. You see that with respect to time, he has given that chart. You see below.
Okay.
It is clear, no?
Yes, it is clear.
Yeah. So, but we cannot do the dynamic analysis, no, unless we do the FEA. So.
Means you are thinking that this is the dynamic load.
Yeah, right. Yes. You see that he has given. If you see PIC 1 and PIC 2. And he has written also, if you see where the loads are given, there in PIC, for example, for axial force, he said 1 or 2. Means he has given how much is minimum, what is maximum. Some stat actually he written, but that is, I think, I don't know what is stat and what is start. I don't know.
I think
actually, he didn't mention clearly what is stat. Is it static load? It's not clear actually. He didn't put it clearly.
Anybody want to answer?
Static is greater than max.
Yeah, I don't know.
But actually, means you are saying that this is the dynamic loads.
Yeah, sure, definitely it is a dynamic load.
But
Yeah,
even
minimum maximum is given.
yeah,
And below that he is giving that curve also. No, you see with respect to time he has given.
Yeah, but this with respect to time and that given, it's for there maybe the motor what he connected to this vessel.
No. You see this design loads on agitator support. You see this is load only, external load.
Yeah, so this is on the support. These loads are means.
No. Support in the sense support is our nozzle actually basically.
Yeah, but then these values directly the values of these loads. It's not a dynamic. It's just a axial and whatever lateral bending, whatever is given.
But I see it as a dynamic only. So because he has given minimum, maximum, and he is giving that that he is giving that curve also. You see that he has given a chart.
Yeah, chart given, but it's not applicable to our nozzle. I think this is applicable to his motor which he is placing for on that our nozzle on that our.
No. If you see this picture.
Mm-hmm.
Actually, support means the basically nozzle only, because your agitator will be supported on our nozzle only.
Yeah. For this type of jobs, where directly what your maximum value is given, no, we added that one.
Yeah, that's what. So other vendors, they will write equivalent static load like that. They will clearly write this much load and this much movement. They will give it.
Mm-hmm.
But this particular vendor has given something like this. He's also added so many notes, something, the dynamic part of the lateral force and bending movements is revolving. Calculation of dynamic load is done without regard to the vessel pressure. And he has added so many, he put so many notes. So,
but these notes all is applicable, applicable to our nozzle, or it's applicable to his motor, which is.
No. It is why for the motor why he will give, because it is clearly for the support only. Support means it is our nozzle.
Mm-hmm.
Okay, so yeah, I think Mr. Neeraj is saying something.
Yeah, Neeraj, you want to add something?
Yes, Ramakrishna, this one is basically for the nozzle only, where the actual agitator, your lantern, and
Yes.
entire shaft will sit on top of it, right?
Exactly.
But,
Right.
but
Yes.
if you see the note number 3, agitator support must be checked with the, no, note number 2, calculation of the dynamic loads is done without regard of the vessel pressure. So the load which has been given over here, you have to put it this its value, F value and M value in the PV line with maximum and average. First you check with the maximum, then this nozzle will sustain. Then I don't think you will have to worry about anything, because if something has to be calculated in the graph, then they will have to provide the basic value also in the graph. But they have given directly readings over here. So you have to take this maximum, FA, FC value, FA or FQ, and then your moment. So these 4 things you put into the your occasional load in a PV light, WRC column, and try to check.
No. Actually, it is occasional load is for once in a while, but here it is continuously changing because it is a continuous rotation. Yeah, that's.
Then you have to go with the suspended load.
Yeah, exactly. So that's what. Yeah, exactly. So that's what. Yeah. So actually, normally I think some multiplication factor will be there. Means if it is a dynamic, they'll take maybe 2 times or something like that. So that I am not knowing if somebody can add it. Or anyway, I will anyway check to go back to the vendor and I will clarify with them. So if somebody finds some answer later, you can just put it in the group.
Yeah, as Neeraj said that we have to take the maximum one. So we also done with maximum one. Also, you can check with vendor.
No, but here the catch is see. Then you are saying, suppose if it is a cyclic load, okay, and there is a maximum minimum, I will design only with the maximum and that is enough. No, it is not like that, no, because it is like a fatigue analysis has to be done. So then in that case, it is different, right? So that's why I think some kind of a dynamic analysis to be done. I mean, if we have to go with this, so that's what I feel.
Okay, Anshu, you want to add something?
No, actually not.
Okay. Abhishek, you have something?
No, sir, but what actually, there are 2 types of sources, actual and but I understand there are technical like
Didn't get you clearly. Your voice is breaking.
So what I hear, there are 2 types of loads, natural, lateral. Yeah, I understand there are loads. Like axial, lateral, and transverse. What is transverse?
No, I didn't get you. Can you repeat your question again?
Your voice is breaking, Abhishek. Can you?
I think that here the transverse mentioned. Here 3 types of loads apply. Axial, lateral, and transverse. This is not mentioned. Any specific that transverse load is not acting here?
No, here there is no transport, nothing. Here the.
No. See why transfer is not mentioned, because it sits on a head. So this is a resultant of longitudinal direction and circumferential direction. So it is a square root of that one, you can say.
Yes.
You can consider like that. Even for the bending moment also same. So it is also he has given for a it sits on a head, so there is no direction. It can come in any direction. Okay, so that is the resultant. So if we want, we can resolve also, or we can put in any one direction. That analysis doesn't make any difference. Okay, I think fine. If somebody gets any else, you can just add in the group.
Yeah.
So yeah, and I have another question. I will just stop sharing this one.
Atul Sharma, you want to add something in this one? I think Atul is silent. Okay.
No, sir.
Okay.
Yeah, and I have a question. Anybody having any experience with this electrical tracing? How it will be supported? Any experience? What kind of supports is required, or whether supports are required at all or not?
So electrical stressing or heat stressing? Heat stressing.
It is electrical tracing, not heat tracing.
So that kind of copper wire will means it's copper wire.
Yes.
It is to be bound. It is to be wound on the vessel or piping.
Yeah, it is a vessel.
Hit that by particular pipe.
Yes.
To maintain the temperature of the process. Yes.
Yeah. So, I mean, should we need to provide any supports at this point of time, or they can manage at site?
They can manage at site. We always doing this kind of job at site. And special contractors are available.
Yes.
You do not require to, but only you have to provide length of wires and how much heat you required and the size of the cable.
Yeah. So that anyway will be taken care by electrical department. So I need not worry about it. But only thing is there is electrical tracing is required. So and if I have one more question. This particular vessel has electrical tracing also, and it has insulation. So first they will complete the electrical tracing, and then over that they will do the insulation.
Correct, exactly. Because if your this process piping or this thing is in the Europe region, then they have to maintain the temperature at the same time they have to provide the insulation outside the pipe. So first will come this heat tracing or electrical tracing, and then the insulation.
Now, in our case, it is actually, some minimum temperature has to be maintained. That the material is actually it is liquid plastic. So it has some temperature has to be maintained so that it will stay in the molten state.
Correct.
So that's why. So it is for our Indian job only. Yeah. But.
So so it means that plastic will be immediately solid up even in Indian temperature.
Yeah, it is not actually, it is not exactly, it is a plastic actually, it is a powder, it's actually a polypropylene plant. So it is actually, it's not fully product actually. So it is in between.
So this heat tracing, as per Neeraj, it's with on the vessel to heat that one vessel, and this insulation to avoid any direct touch or any heat loss from that one, right, Neeraj?
Correct. And actually, to hold that wire, there is one silver tap is also required.
What is that?
Silver tap.
Silver
which will hold the entire. Yes, it will be provided by the supplier, contractor.
So then in because we did not provide any welding or anything, you know?
Nothing.
Okay, they will take care at the site.
Yes.
Okay.
Yes.
Okay. Because our PMC is asking, if any, how please provide the details. What kind of support will be provided, things like that. So that is his question.
But Neeraj, this heat tracing similar to this insulation support will provide anything like that?
No, insulation support itself is a mechanical item where the mechanical engineer comes into the picture.
Yes.
Where they have to provide support, insulation bolt, insulation nut, insulation pleat, insulation clamp kind of things are there. But here heat tracing will be automatically, means you have to just keep it into it should be 100% touch with the particular pipe or equipment.
Yes.
By some kind of silver tape is there. I forgot the name of that tape. So that is to be provided by contractor.
Okay, with the tape only it will be stick to the vessel. It's nothing is
okay. So no welding business.
Yes. No.
Yeah, thank you. I am relieved.
Okay, any more, Ramakrishna?
Yeah, that's it. These two issues only.
Okay, Anshul, you have any more?
No.
Abhishek?
No.
Atul Sharma?
No.
Neeraj, did you find anything? Any in our
It was nice talking.
Yeah, did you anything you want to share or anything you want to ask after this discussion? Okay, then can we wind up?
Yes.
Yeah.
Yeah, yeah. Okay then. Okay. Good night.
Okay. Thank you.
Good night.
Good night. Yeah.
Bye.
Thank you. Thank you.